My name is Darshini Shriman, and this is Lab 4, the Circuits Lab of Physics 2212. So a little introduction into this lab. The purpose of the lab was to predict behaviors of circuits containing resistors in series and parallel, to use multimeters to measure the actual values of conventional current and potential differences in the circuits, and examine the behavior of ohmic resistors and capacitors. And then a little introduction for the results. In the current loop with 47 ohms and 100 ohms, we got that the value was 0.02 amps. And then for the RC value that was calculated using the linearization model, we found that that value was equal to 5.988. And then the assumptions that we had are that resistance of the wire is negligible. So some key concepts to understand. We have the conservation of energy and charge, and then Kirchhoff's circuit laws. So this is an example of one of the laws, and this includes node as well. And then we have Ohm's law, which is V is equal to I over R. Resistors and capacitors in series and in parallel. So again, just being able to understand the overall calculation of this. And then the capacitance value, which is here, and then time dependence in RC circuits. So this is the linearization of that calculation. This was our experimental setup for the first part of the experiment. So for the series circuit, we found that with calculations, the intended value of the current was 0.02 amps, and then the actual value measured was 0.02 amps. And then reversing the ammeter makes the value negative, and then replacing an ammeter with a voltmeter results in the current being 0 and the voltage being 300 volts. Now for the potential values, we had A, B, C, D, and E, F with the only ones being defined, and A, B, C, D, and E, F as a whole, adding them together using loop rule, should have equaled 0, and in this case it did. So that proves the validity of our results. And then this is the resistance calculation for the 47 ohm and 100 ohm resistors, the wire, and the ammeter. We got 48 and 102. And then this is the completion of that graph that was basically measuring the overall resistance of the For the RC circuit, we didn't have a picture of it. Basically, it was the battery connected to a voltmeter and connected to a light. And when disconnecting when disconnecting the circuit, it causes the light to diminish. So for the 10 ohm, we found that the time to charge was 13.3 seconds and the time to discharge was 10 seconds. For the 20 ohm, we found that the time to charge was 23 seconds and the time to discharge was 18.1 seconds. Now using the linearization model, we took a bunch of data points within 0 and 20 seconds and linearized it due to this natural log right here. And based on this, the expected RC value would have been 6, and then our calculated RC value is the slope of this graph. So it would be 1 over this value, which is very close to 6, which means we were successful in our measurement. So possible sources of error that can be found. Number one, there could be problems with the equipment. There could also be errors in time calculations due to not measuring fast enough or accuracy of timers. And then assumptions for the wires and ammeters are not necessarily true because there is resistance in these tools. So for this lab, since we did it in person, the online simulator would have given more exact ideal values. And then for the real time versus the online simulator time, the real time is slower because the battery does have resistance, kind of relating to the possible sources of error that we could have had previously. Thank you for watching.